Today we are going to start to create this magical blast effect from start to finish using geometry nodes. In this demo, I actually use one huge node graph, but this time around we create each element separately and later link them to one. It will be easy to understand, easy to explain, and above all, you will be able to create so many different variations of magical effects. To start the journey, today we create our major element, a beam. To get started, we need an object to be our beam. Create a plane, and we also need 2 points in space where one will be our start point and the other to be our impact point, the end point. So let's create two empties and rename our objects to beam, start and end. Now move our endpoint to somewhere around here. Go to Geometry Nodes workspace and create a new node setup and rename it to beam. Drag our two empties to the setup and set both of them to relative. Let's create our beam. For our beam, I'm going to use a curved line. It's a 2-point curve, simple as that. Here we can set the position of our 2 points in the start and end. As you already guessed, let's drag the location output of each of these points start to start, end to end. Now I can move these empties and our curves will move according to that. Now we need to turn this to a mesh. So curve to mesh. To see the result, we need to plug a curve shape to the profile curve input. So drag from the profile curve socket, and as soon as you let go, you will get this search option, and I am going to search circle and select curve circle. In this way, you can easily add any node if you know their name. Since I do not want to have a uniform radius throughout our beam, I am not going to change it from here. Instead, I am going to add a set curve radius node before the curve to mesh node. And here we can do whatever the hell we want with our radius. To change the radius, we need a node that contains some kind of curve data. I'll add a spline parameter node. This factor will give us a 0 to 1 range value, 0 being the start point and 1 being the end point of our curve. I plug this into a radius socket. Look at that, we got ourselves a cone. Again, start point being 0 radius and end point being radius of 1. But note that here it kind of works like a multiply node. Any value you plug here will multiply with this master radius node. For example, if we change this to 0.5 meters, then since our endpoint value is 1 from the spline radius node, this will output a radius of 1 multiplied by 0.5, which means 0.5. If we change this to 2 meters, then output will be 2 meters. But still, we have basically no control of the radius other than this, right? So I add a map range node. Like the name suggests, it will map whatever the range of value we provide and gives us some more controls over it. It's basically the color ramp node, but more powerful and easy to use. Here in the 2max slot, I can change the maximum value of our range to whatever the number we want. Same to the minimum. Now, like I said, it will multiply with our master radius. Right now, I set this value to 1, 1.1 and 0.2. You can change those to any number. Since we got our basic shape, let's blast the beam. There's no blast node, so let's use trim curve node. This will trim the curve from start or from the end. Here we want the end value. Later we will need both values, but right now just this one. Now we need to create that wave effect. In a previous video, we created that ripple effect by displacing the mesh using distance and modulo math nodes. Here we are going to displace the mesh using sine waves. To displace, we need something to displace. Here we only have just 2 points. So let's resample this. Add a resample node and set the count to 16. Let's go with 32. Now you can see the difference in the wireframe mode, before and after. Let's use a set position node to displace the mesh. I drag the spline parameter factor to offset. This will offset the curve on all 3 axes. Since our endpoint value is 1, the endpoint will displace 1 meter on x, y and z. But I only need to displace on the z-axis, so let's use combine xyz and drag this to z socket and set x and y to 0. Now we got everything set up for our sine wave. So let's add a math node and set its math type to sine. Let me explain the sine wave a little bit. If you know sine waves, then feel free to skip this part. This sine graph here shows what is the value of sine theta when we change the theta. Theta is the angle. When we increase the angle of theta, it will show a value that looks like a wave pattern. Here, all we need to know is these few things. Value will never go below -1 or go higher than +1. Once we complete a 1 cycle of 2π, this wave also completes a cycle, which means it will reach the same value. Here, what we're going to do is we use this curve and change the wave count, change the strength, and the offset. Let's do those in geonodes. Here, since our factor gives us a value between 0 to 1, we can't really see much effect. But look what happened when we change the range using a map range node. So if I change this value to 2π, theoretically we will see a full wave, right? Let's see. 5 means this, so 2π means I'll copy this value and paste. We got it. Actually, here in this setup, I consider half cycle as a one wave. It feels easy for someone to understand, I think. Yeah. So I add another math node, change it to multiply, and plug it to 2𝒚𝒐𝒎𝒃. I change this value to 5. You can just type 5 and Blender will know. Now, using this second value, we can change the amount of waves. Right now, it's a float value with decimals, but later in the video, I changed it to integer. So we got the waves. Let's change the strength of it. Simple. Use a multiply node. That's it. Now to the offset. So we got our ranges. If we can move this range left or to right, see, that means to offset the wave we need to offset the range, which also means we need to add or subtract a value from our range. So let's add a math node and add a value. We are getting the offset, but I like the waves to move forward when I add positive numbers instead of negative. So simple fix is set the math type to subtract. Now instead of adding a negative value, we are subtracting a positive value to move the wave forward. It's exact same thing. I actually don't need the endpoint and start point to have the full effect. So I use a color ramp and set the two ends to black, which means 0, and add another slider in the middle and set it to 1. Now multiply this with our wave. See, I think it looks more like a real magic blast. Although I haven't seen a real one or a fake one. Okay, if you want, keep it, change it, or delete it. We set up the beam. Now we can set a material to it. I actually will do a video on materials and UVs after we finish setting up the basic elements. Now to finish, let's extract all the variables values. I'll drag each input to the group input node and give it a proper name in the group panel. Same time, I give it a reasonable minimum, maximum, and a default values. I drag two objects inputs, resolution, radius, trim curve inputs, our wave amount, offset, and strength, and also the material. Here in the wave amount input, I change it from float to integer. Now we have a more user-friendly wave system. So that's it. That's it for this part. Next part, we'll do the spiral element. So if you learn anything, that's great. I mean, that's what we like to do. We not only create stuff, we let you create with us. Hit that like button, comment your thoughts below, and don't forget to subscribe to HelloFX Learn so you won't miss out when the next part drops. Also, you can support the channel by becoming a Patreon member. So until next time,